Today we are going to work on blending example. In this kind of example, we have number of input variables, and the decision variable is all about how to mix these variables to reach the intended quality and meet some other constraints. So suppose we have x1 and x2 as our input. We want to mix them to reach a certain quality level and produce two outputs. For example, two outputs, y1 and y2. This mixing is going to be the condition variable. Mixing plan. It's the input, output, and the decision variable. And we have some constraints regarding the quality and the amount of our input or amount of supply. Okay. Right. So then y1 and y2 must not exceed the supply, or it should not go above, for example, the amount of x1 and x2 or supply. So we have these two constraints regarding the quality and the supplies. But we have to determine how to mix these inputs to reach certain quality level and also to maximize our profit. Profit or revenue. So revenue, total sale, whatever is going to be our this objective variable. Our decision variable will be the mixing plan, and our constraint applies to quality and our supply. So take a few minutes to read this example from your textbook. Example 14.2. On Monday, we worked on example 14.1, and I uploaded the solution to that example. Please make sure to develop those models on your machines. And now let's go and interpret this example line by line. Okay. Can I erase this one? Okay, Chandler Oil has 5,000 barrels of crude oil 1 and 10,000 barrels of crude oil 2. This one is going to be our supply. Crude oil 1 or X1 one 10,000 barrels available. Oh, sorry, 5,000 barrels of oil 1 and 10,000 barrels of crude oil 2. X2 is going to be crude oil 2, and we have 10,000. These products are produced by it sells gasoline and heating oil. So we have these two inputs and we have two outputs, Y1 and Y2. The outputs are gasoline and heating oil. Okay. These two products, these two inputs must be mixed to produce heating oil or gasoline. Each barrel of crude oil has a quality level of 10, crude oil 1, this one, Q1 must be 10, and each barrel of crude oil 2 has a quality level of 2. And here we have Q2 equals 2. Oh, sorry, 5. Gasoline must have an average quality level of barrel crude oil. Gasoline must have an average quality level at least 8. So I will Q3 or Q of output 10, at least 8. And heating oil must have an average quality level of at least 6, Q4. When it says at least, at most, these are all constraints. We have to meet these constraints. So this quality is better to write it this way. At least less than or equal to 8. Average quality level of 6. Gasoline sells for $75 per barrel. And heating oil sells for $60 per barrel. In addition, if any barrels of crude oil are left over, they can be sold for 65. For leftover, sells $65, and crude oil for $50. Respectively. Okay, we assume that demand for heating oil and gasoline is unlimited. We don't know the demand. So that all of the Chandler's production can be sold, Chandler wants to maximize its revenue from selling gasoline, heating oil, and any leftover. So here we just have the same price. We have access to only revenue. We know nothing about the cost. So we want to just maximize it. And the variables that are in our hand, in our control, are how to mix these input variables to be able to maximize the revenue. So we have these constraints. Quality of gasoline must be at least 8, quality heating oil must be at least 6. And here's our supply. Our produce must not exceed these numbers, 5,000 and 10,000. And we want to mix them in a way that our and total revenue. Create from selection. You can get the list of variables from this menu, name manager. Available, barrel sold, blending plan, leftover, quality obtained, quality required, left, total revenue, and used. We have defined our variables, or we have defined range for these variables. Now we need to connect all these variables, constraint and objective, to the decision variable. We can enter some trial values here. 1, 2, 3, 4. But Excel will change it later. Used is going to be the summation of these two. Summation of gasoline and heating oil. Used must be less than or equal to available. This is our first constraint. And leftover is going to be this one, minus available minus used. Equals available minus used. The second constraint is about the quality. The obtained quality must be at least equal to the quality required. So the quality required, quality obtained must be bigger than or equal to the quality required. Yes, yeah, quality obtained must be at least quality required. Now for gasoline, how can we calculate the quality obtained? I missed this part. Barrel sold, that equals summation of these two. This one equals summation of heating oil. This is going to be the barrels sold. Okay. So the quality obtained that equals obtained quality. I think it is going to be the sum product of this one by quality obtained. Quality level of crude oil 1 okay, this is going to be the multiple. This one, crude oil 1 and 2 times quality level of crude oil 1 and 2. Yeah. The amounts used times their quality level. This one equals sum product of quality level and amounts used. For heating oil, oh, I made a mistake here. It has to be B13. Crude oil 1 and 2 for gasoline times quality obtained for gasoline, crude oil 1 and 2 times quality level of this one. For heating oil, it's going to be the sum product of the quality level times this amount. And the required quality, this one must be bigger than or equal to the quality required. The required quality this one, row 9, and barrel salt for the gasoline. Is going to be B8, B9 times number of barrels sold. B15. Can you please check on the textbook, see if I'm on the right track? Right. Yep. And this one equals quality required for heating oil is C9 times the number of barrels sold, C15. And it has to be bigger than or equal to. Total revenue equals sum product of value per barrels selling price per barrel, this one, and selling price barrels sold times this one, plus the price of leftover. Again, some product of leftover times this one, right? Yeah. It's $5 less than the regular sale. All right, here's our model. Now, all these variables are connected, and we just entered some trial values for the decision variable, which is this part. Let me color it orange. The total revenue is our objective variable, and we have some input variables and other input variables, and we have two constraints. One constraint here, let me color it green, and the next constraint is here. So now we can go to data menu, select solver. Here we can define our variables. The total revenue is going to be the objective variable. We want to maximize the revenue. Select this one. Decision variable is going to be the blending. We named it blending plan. And now we can define our constraints. The first constraint is that used must be less than or equal to available. Used, available. And the second constraint, quality obtained must be bigger than or equal to the quality required. Quality underline obtained must be bigger than or equal quality required. The underline required. Yes. At maximize blending plan, quality required obtained must be bigger than quality required, used must be less than available. We check this one for non-negativity and we select simplex linear programming. And now let's see what we get as a result. Okay. So here's the mixing plan, the optimized mixing plan. And with that number, we can reach the total revenue of $975,000. Here's the maximum revenue that this company reached with that oil, with that blending plan. And you see that all these constraints are satisfied. Use is less than or equal to the available, leftover is 0, and quality obtained is bigger than. This must be bigger than or equal to quality required. So these constraints are met, and here's the optimal value for the decision variable. Does that make sense?
Yeah.
Okay. Next week, after the midterm exam, I will ask you to work on different kind of examples. I will give you as quiz, and you have to complete those quiz on your own. Right? So make sure to practice these models on your own, and I will upload the solution after the class. Any questions?
How is the plan going to be set up? Like, is it going to be like the first homework and quiz, kind of like with the Excels?
Yes.
Or what?
Yeah.
Okay.
You have to work with the Excel. Very similar to the to assignment 1.
Okay.
Yeah.